Welcome back to Principles Engineering. We're working on our truss diagram, and now we are at point A. So looking at point A, let me highlight that. We're going to recreate a free body diagram for that. So let's go ahead and draw in point A. And there is our node, or our joint. And I have got a couple of forces working on it. The first force that I have is this is my force AB, which I just found when I analyzed point B, and that's 500 pounds, and I know that it is pulling because it's in tension. There. My next force that I've got coming down here is going to be the force AD. Now I've drawn that in tension, but looking at it further, I think I'm actually going to put it into compression, because it makes more sense to me, and we'll talk about why here in just a second. So those are all the forces that I have working in here. Now one of the things I can do is I can break the force AD just like we did back at point C, but I can break this force into a component which is an X component going this way, F A D X, and a Y component, F A D Y. Now I know from my diagram that this angle right here, theta, is 45 degrees. So that should give us some hints on how to proceed. So let's talk about our basic premise, and that is that if the point is not moving, so at point A, the summation of the forces in the X direction have to equal to 0. Similarly, the summation of the forces in the Y direction have to equal to 0. So it doesn't really matter which one we start with, but let's go ahead and start with the summation of the forces in the X direction. But before I do that, I notice that I've left one force off. So I apologize for that, but I've got this external force right here, 500 pounds down. Okay, so 500 pounds down. So let's start out in the Y direction. So I'm going to do that in green. So what I've said is the summation of the forces in the Y direction has to equal to 0. So what I've got in the Y direction is I have a minus 500 pounds, which is my weight, plus the force ADY has to equal to 0. Right there. We can simply solve this, and we can say that the force ADY has to equal to 500 pounds. And that is up, or positive. That's how I've drawn it right there. So let's go ahead and write that in red and say this is 500 pounds up. Now from that we can think about our unit equation here, and we can solve the rest of this vector really quick. So I've just said that I've got 500 pounds this way, and I'm going to take the units off, just use the numbers. And I've said I've got B here, and I've got C here, and I know that's 45. From this, I know from my sine rules that the sine of 45 degrees equals to my opposite divided by the hypotenuse. Or, in terms that I have, my opposite is 500 pounds divided by C. So it's a pretty simple equation. I could say that C is going to equal to 500 pounds divided by the sine of 45 degrees. Real straightforward. That's going to equal to 707 pounds. Now it's positive because it is in the up direction, and that just means that my sign is correct, so it's pushing in compression. So 707 pounds in compression. Now C here equals to FAD. Let me highlight that Y. So here's my FAD. You'll notice that is there, there, there. Pretty straightforward. So what does B equal to? B equals to FADX. So let's find that. Let's find FADX. And I know from Pythagorean's theorem that A squared plus B squared equals to C squared. So I now know C squared. So what I can say is 500 squared plus B squared equals to 707 squared. And it reduces down to B squared equals to 707 squared minus 500 squared, or B equals to 500 pounds. So pretty straightforward there. Now, this is kind of an important concept to understand because we drew that unit triangle. It is left. The way we drew the unit triangle, it would be negative, so I lose my sign. But this ends up being 500 pounds. Now, why do we care about that? That's one way to find it. What's the other way we could have found it? The other way we could have found it is we could come back in here and we could say that the summation of the forces in the x direction has to equal to 0, which would mean that FAB plus FADX equals to 0, or FADX equals to a minus FAB. FAB is 500 pounds, so minus 500 pounds FADX equals to. So two different ways to find the exact same thing. We get the same answer, 500 pounds left. So that's our forces at A, just showing you a little bit of extra math there on how we can do that. So let's go back and update our master diagram, our force diagram. So we'll come over here and enter in. This is 707 pounds. Oops, they put it in red. £707, and that is in compression. So compression because it's pushing the point. So 707 compression. Hopefully that all made sense. Thanks for watching. Last point is point D. Next up.